voltage control. What is this voltage control? Why we have to do it? So if you consider a transmission line, it will have a sending and a receiving end, right? So sending end voltage we take as Vs, and the receiving end side the voltage we take as Vr. Okay. So whatever voltage that we set here, the sending end voltage, it can be fixed. Now what about the receiving end voltage? This is going to vary on the load that we connect, right? Whatever load we connect here, it is going to depend on that. Why is that the case? Because Vr is equal to the sending end voltage minus the voltage drop across the transmission line, right? And the voltage across the transmission line, it will depend on the current that is flowing through it, right? And the current in turn, it will depend on the load. If there is no load, then what will be the current drawn? The current drawn will be 0, right? So this drop that we have along the transmission line, that is going to affect the receiving end voltage. Okay, and it's always, we always want the receiving end voltage to be within a specified limit. So maintaining the voltage levels at receiving end is important for the satisfactory operation of all the equipments that are connected. All the load that we have, they are going to have a voltage rating, and they need to be given that voltage rating. Okay, so we want to maintain the voltage within specific limits. Okay, but whatever load is connected to it, that is not dependent on the distributor, right? Whoever is supplying the voltage, the power supplier, they are not going to decide how much load is being given to them, right? It will depend on the customers. So if the load cannot be controlled by the supplier, then what can the supplier do so that this voltage level is maintained? The key here is the reactive power. Now how will the drop depend on the reactive power? For this we will take the example of the short line model, right? For a short line, there is going to be only resistance and inductance, there will be no capacitance, right? And for this kind of short line, we have already discussed while we were discussing voltage regulation that the drop delta V, this is going to be IR, we are discussing only about the magnitudes, IR into R cos phi R plus X sin phi R. Okay, so R is the resistance of transmission line and X is the reactance of the transmission line, right? Now this expression you can multiply and divide by the receiving end voltage, then you are going to get this expression divided by mod VR. Now what is IR VR cos phi R? This is the active power, right? Receiving end side active power, and IR VR into sin phi R is going to be nothing but the reactive power at the receiving end side. So this expression you can write as R resistance will be as it is, and PR plus X QR divided by mod VR. Okay, when the resistance and the reactance are compared, the resistance is going to be a much negligible value. Okay, so we can take an approximation, the delta V, this is all delta V, magnitude of delta V, right? This we can approximate as XQR by mod VR. Okay, so here we have considered R is very negligible value. Okay, so here you can see that the voltage drop is almost directly proportional to the reactive power. Okay, so if we want the voltage drop to be less, then reactive power should be as minimum as possible. Okay, so you can write this delta V is proportional to the reactive power at receiving end. Okay, so in order to reduce the voltage drop, reactive power should also be kept as minimum as possible, should be reduced. Okay. Now if reactive power should be reduced, it means that the power factor angle should be reduced, right? That means what will happen to the power factor? If power factor angle is being reduced, then power factor is going to improve, right? So this implies that power factor angle at receiving side, right? So phi r, this should be reduced. So this means that the power factor, which is cos phi r, it will be improved. Okay. So power factor can be improved to reduce the voltage drop. So this is how you can see it in terms of reactive power or in terms of the power factor. Okay, either is the same thing.